On behalf of the NCSEA Board of Directors, welcome to the 28th NCSEA Awards Celebration. My name is Emily Guglielmo, and I'm the current president of NCSEA. While we wish we could have celebrated in person, NCSEA is excited to have this opportunity to continue our tradition of honoring and recognizing individuals and firms for their excellence. This special video awards presentation will highlight the recipients of the NCSEA Excellence in Structural Engineering Awards, which honor excellence and creativity in structural engineering. This video will be available throughout the year to provide a lasting memory of all the successes of our industry. I will now turn the virtual podium over to Carrie Johnson, Chair of the NCSEA Awards Committee.
The Excellence in Structural Engineering Award winners were selected from 93 entries representing over $19 billion of construction. Each year, I am amazed by the quality, innovation, and creativity of our award submissions, and each year they truly highlight the best that our field has to offer. Judging was done in two phases. The first round of judging was done by NCSEA past presidents. The second round was done by structural engineers from our Northeast Coalition. Our thanks to both groups for their time and expertise. The judges selected the winning projects based on creativity, complexity of the project constraints, innovative application of materials or techniques, exceeding the client or owner's expectations, and suitability of the structure for its environment.
The Structural Engineering Excellence Awards are divided into 8 categories. Winners in each category are highlighted in future issues of Structure magazine. As this year's winners could not be recognized in person, they will also be honored at the 2021 Structural Engineering Summit. Each category has multiple winners, and one winner in each category will be named the Outstanding Project. In the New Bridges or Transportation Structures category, the winners are 707 5th Manulife Place Pedestrian Bridge. 707 5th Manulife Place Pedestrian Bridge serves as an important link in Calgary's elevated network of pedestrian pathways. It was a challenge that required innovative solutions, providing a seamless connection to adjacent buildings while managing subgrade conditions, installation sequences, and non-structural coordination. With a total length of 270 feet and 10 inches, the bridge features an elegant structural system known as a suspended lenticular truss, spanning 96 feet and 5 inches. The Dublin Link Pedestrian Bridge. The Dublin Link Pedestrian Bridge in Ohio was conceived simultaneously as a sculptural form, an efficient structure, and a dramatic experience for visitors and residents. Its critical features of the eye-of-the-needle central pylon, sinuously curving deck, an unusual single-sided suspension method combined to create an architecturally unique, spatially impactful, and structurally innovative locus for the city's urban renewal. LaGuardia Airport Pedestrian Bridge B. LaGuardia Airport Terminal B was a dramatic departure from traditional terminal design, relying on concourse islands to increase efficiency and trim years off the construction schedule. With mere weeks to prove it was structurally feasible, the team used cutting-edge parametric optimization to put forth 450-foot-long bridge trusses that met challenging depth constraints and surpassed vibration requirements. And the 2020 Outstanding Project in the New Bridges or Transportation Structures category goes to the Dublin Link Pedestrian Bridge.
The judging committee chose the Dublin Link Pedestrian Bridge as the outstanding project for several reasons. First is an iconic structure, which is described as an eye of the needle. It is the largest single-sided suspension S-curve bridge in the world. The Dublin Link ties the eastern and western sides of Dublin, Ohio together. Lastly, to create this unique structure, the design team had to utilize principles of geometric optimization and stress shaping to create a maximum impact, all while using minimal material.
The iconic and expressive design of the bridge is an exemplar of Ender Studio's design ethos of creating architecture with a strong sense of place and a deep connection between structure and space. While we are incredibly proud of the Dublin Link and our team's solution to the significant technical challenges with its construction, We are especially energized by how the project has been accepted by the community of Dublin and its surroundings. During this challenging time for our exploring public space, we loved seeing photos of the bridge being safely used by families getting some fresh air, people walking their dogs, and even a number of wedding engagements popping up on social media. We would like to thank the City of Dublin for their commitment throughout this project, in particular, Terry Fogler and Megan O'Callaghan. We would also like to thank and recognize Dan Fitzpatrick and Mirk Olmar and their team at TY Lin for their commitment to realizing our vision for this iconic project, and to the entire construction team at Kokosing for their attention to detail, craft, and precision.
In the forensic, renovation, retrofit, and rehabilitation structures under $20 million category, the winners are 28 Liberty Street Subcellar Retail Conversion. The newly renovated subcellar floors of historically landmarked 28 Liberty Street in Manhattan required extensive structural design work, including a new interfloor escalator opening connecting 5 floors. This involved the simultaneous removal of 2 axially loaded floor framing members on 2 levels and the redistribution of their respective axial loads via a new double truss system. The trusses were constructed on the floor, lifted into place, fixed to the existing framing, preloaded against one another using hydraulic jacks, and the existing framing was removed in incrementally increasing dog bone type cuts in the framing. First Unitarian Society Meeting House. A National Historic Landmark, the First Unitarian Society Meeting House was designed by Frank Lloyd Wright and completed in 1951. The underdesigned center-hinged arches have settled significantly over the years. Pierce engineers designed a pre-tensioned, cold-formed steel hybrid truss that could be installed in a small attic with significant sight to take load off failing trusses without the use of shoring to transfer load. Napa County Historic Courthouse. Built in 1878, the Napa County Historic Courthouse, a 2-story, 15,000 square foot unreinforced brick building, was severely damaged and red tagged in the 2014 South Napa earthquake. The initial survey phase utilized field observations and 3D scanning to understand global building behavior via the creation of a detailed BIM model. Repair work included one of the first applications of fabric-reinforced cementitious matrix in California, plus concrete masonry unit rebuild in areas of heavy damage, along with traditional brick repair techniques. West Virginia State Capitol Building Inner Dome Structural Repairs. The historic inner dome and interior supporting walls of the West Virginia State Capitol Building were found to have structural deficiencies. 3D finite element analysis modeling and laboratory testing were used to determine material properties for the unique coconut fiber reinforced plaster elements that comprise the cast gypsum plaster shell of the dome. Repairs were designed to strengthen portions of the existing structure and incorporate supplemental supports to support the dome in place while the walls beneath the dome were completely removed and rebuilt. And the 2020 Outstanding Project in the Forensic, Renovation, Retrofit, and Rehabilitation Structures under $20 million category goes to West Virginia State Capitol Building Inner Dome Structural Repairs.
The judges were impressed with this creative solution involving unique materials. The solution for this historic dome involved determining the material properties for coconut fibered reinforced plaster elements that comprise the original plaster inner shell of the dome. WDP and Associates' unique solution utilized adding supports to the outer shell and creating a new masonry ring, allowing the walls below to be completely removed and rebuilt.
The structural repair project posed several unique challenges for both WDP and the construction team that required creative engineering solutions and careful implementation of the repairs. As a historic structure iconic to the state of West Virginia, the project had to preserve the aesthetic qualities of the dome, incorporate the repair and strengthening materials in a historically accurate manner while complying with the State Historic Preservation Office in both design intent and implementation of repairs. As a unique arrangement of components, the building itself presented numerous challenges, such as discovering the interior plaster of the dome was primarily attached to the structure with coconut fiber reinforced wadding, for which no material properties were available, and realizing the original hangar system had failed, and interior ornamental clay tile walls that were to be rebuilt had buckled and displaced and were now bearing the weight of the inner dome as a result of failures throughout the structural system. Through each of these challenges, the design team at WDP, led by Jody Narowski, Patrick Dillon, Akshay Benawal, BJ Lee, Chris McKinley, and so many others within our firm, provided innovative and comprehensive solutions, and together with the support and partnering of the West Virginia General Services Division and the excellent team of managers and craftsmen at Pullman, without whose professionalism and excellent workmanship this project would not have succeeded, we are proud to have helped preserve this iconic structure for future generations to enjoy.
In the forensic, renovation, retrofit, and rehabilitation structures over $20 million category, the winners are Google Spruce Goose. Arab has transformed the Spruce Goose aircraft hangars built in the 1940s and originally used by Howard Hughes into modern office accommodation, rehabilitating and seismically upgrading the existing timber building to current code requirements and to create 4 new levels of office and film production spaces. Retrofit measures included the use of up to 52-inch self-tapping wood screws, heavy steel, multi-tier braced frames, and steel tie rods to limit deformations of the existing structure under seismic loads. Stanley A. Milner Library Renewal. Located in the Civic Century of Edmonton, Alberta, the newly expanded and rejuvenated Stanley A. Milner Library serves as a multi-purpose facility for the local community. Fundamental to the library's new identity was the transformation of the existing monolithic concrete facade into a strong architectural expression. Fast and Epps' ingenious solution comprised a complex truss system which cantilevered from the existing structure to transform the building shape. Other features included a new lateral system, a reading ramp, and enhanced open spaces. The revitalized library is slated to open in late 2020 to serve at the heart of Edmonton once again. Yotel. Yotel San Francisco provides 203 compact hotel rooms within the 75,000 square foot Grant Building, a survivor of the 1906 and Loma Prieta earthquakes. Its adaptive reuse from office to hospitality space required a full seismic retrofit that met lofty preservation and hotel programming goals. Engineering challenges included designing the retrofit to high forces, strengthening the frail existing structure within tight spaces, and rising to unforeseen challenges during construction administration, including different owners, architects, and contractors over 12 years. As engineer of record, Holmes Structures was the only constant team member. And the 2020 Outstanding Project in the Forensic, Renovation, Retrofit, and Rehabilitation Structures over $20 million category goes to Google Spruce Goose.
The creative solutions utilized on this project were what really impressed the judges. This transformation of aircraft hangars built in the 1940s into modern office accommodations utilized a multi-tiered brace frame system that had not been incorporated into the building code. These braces were used by Arup to provide strength and stiffness to the existing wood roof diaphragm. The solution also involved retrofitting the existing glulam beams using a cost-effective system that involves self-tapping screws up to 52 inches long.
Working on an existing building from 1943 comes with obvious challenges. You have to understand the as-built drawings and the existing conditions. Then you have to retrofit and repair the existing structure to make it seismically sound and code compliant. And then building a new building inside an existing aircraft hangar comes with limitations and space constraints, which you have to consider in design and detailing of the structural elements. Speaking for the entire team, we are very honored to receive this award, and I think the whole team can be very proud of the work they did on this historic structure and transforming the building into a state-of-the-art office building. I'd like to thank the Arup team, who did an amazing job on this project, and then of course, the whole Google team, CBRE, the architects from ZGF, and Met Construction.
In the Other Structures category, the winners are Caton Children's Museum Courage Climber, The Courage Climber at the Caton Children's Museum is a multicolored tensile structure that spans 1,500 square feet and includes challenges for discovery-based play along the way, with lookout perches, an ascending rope walkway, rocky bowl, rope bridge, and tunnel chute. To evaluate the complex geometric shape, Holmes Structures utilized a parametric form-finding tool and assessed the distribution of loads throughout the use of a nonlinear mesh of cable elements. Through detailing and leveraged prefabrication, field welding was eliminated. Coastal Wall at Northwestern University. Northwestern University's Ryan Fieldhouse and Walter Athletic Center had very limited land and required an innovative solution for their active sports and recreation programs. To maximize the available land on site, the team created virtual land by cantilevering the building to the edge of Lake Michigan. To allow the building to be situated directly next to the coastline of Lake Michigan, Smith Group designed a curved coastal wall to withstand the dynamic waterfront conditions. Mackinac Bridge paint platforms. As part of this 5-mile-long suspension bridge's first stripping and repainting in its 60-plus-year history, engineers designed platforms that allowed for removal and collection of the original lead-based paint and repainting of the bridge's 552-foot towers. The platform was designed as an enclosed, lightweight modular space frame capable of sustaining 100-mile-per-hour winds, a 2-story movable steel and aluminum structure that encircled each tower leg. Davit-like outriggers supported the platform, which traveled along cables to allow painting the tower's upper portion. A second platform consisting of steel box trusses was used for the struts connecting the tower legs. And the 2020 Outstanding Project in the Other Structures category goes to Mackinac Bridge paint platforms.
The judges were impressed by the solutions provided for the unique challenges on this project. The engineers were tasked with creating a painting platform. This was a 2-story movable steel and aluminum structure capable of sustaining 100-mile-per-hour winds. The solution eliminated the need for almost 400 feet of scaffolding. Ruby and Associates also provided erection engineering, construction engineering, heavy lift engineering, and steel and aluminum fabrication detailing services to complete this project.
The Mackinac Bridge paint platform project was challenging in many ways. The primary objective was to provide a system that could encapsulate the lead-based paint removed during sandblasting while ensuring worker and public safety. The platform is essentially a canvas-enclosed structure the size of a 2-story house, light enough to be raised and lowered the 550-foot height of the support towers using a set of hoists, yet strong enough to resist 100-mile-per-hour plus winds. I'd like to thank Moran Ironworks of Onaway, Michigan, who brought us into the design build team and introduced us to Seaway Painting, the prime contractor for the project. Moran offered many refinements to the design and did an excellent job fabricating the intricate platform and assisting in its installation. I'd like to thank Kim Nowak of the Mackinac Bridge Authority, who was receptive to the innovative approach we offered to the challenge of painting these massive towers. I'd especially like to thank Steve Lahakis of Seaway Painting, who brought to Ruby the concept of a hoist-driven modular paint platform and worked closely with us to develop the final product. On behalf of Ruby and Associates, I'm grateful for the opportunity to work on an iconic structure like the Mackinac Bridge in such a tremendously challenging project. Thank you.
In the New Buildings Under $30 Million category, the winners are Ice Block 1. Ice Block 1 is one of the first projects in Northern California to utilize an exposed mass timber structure. The building blends 3 structural materials seamlessly: mass timber at the upper floors, concrete podium at the second floor, and steel buckling restrained braced frames. The 4th floor mezzanine provides a 30-foot volume with expansive views through glass curtain wall. Exposed exterior braced frames on the north and south facades create an authentic expression of structure in harmony with architecture. The Wagner Education Center at the Center for Wooden Boats. The Wagner Education Center establishes a new front door for the Center for Wooden Boats. The dramatically exposed structure, simple yet evocative materials, and energy-efficient design solve the challenges of a limited budget and restrictive site, while supporting the mission of education, interpretation, and hands-on experience in building, maintaining, and using historic small craft. And the 2020 Outstanding Project for the new buildings under $30 million category goes to Ice Block 1.
Ice Block 1 stood out to the judging committee for several reasons. First, the structure incorporated the use of mass timber to recreate a building of yesteryear. To create this, the engineers developed a unique lateral system that incorporated both function and aesthetic to create something that was not only visually pleasing, but structurally sound. Additionally, Ice Block 1 moved away from conventional engineering practices by incorporating multiple construction materials to meet specific building needs.
This project was special for me to work on because it incorporates exposed heavy timber, which aligns with my personal interest in sustainability and also results in an aesthetically pleasing interior as well as exterior. One of the challenges that we had on this project is the exterior brace frames. The architect and the owner were looking for an industrial architectural expression. They were expecting the frames to be non-structural elements since they were outside of the building envelope. However, we were able to merge their architectural vision with our structural needs to make them the primary lateral system. It was extremely rewarding to work alongside RMW architects, Ascent Builders, and the owner, Heller Pacific. The architect, Steve Guest, is really due a lot of credit for his vision of the building, and also to Mike Heller, the owner, for taking a leap of faith with an up-and-coming building style. The entire team had great synergy and collaboration, which made this project a big success, and one that I am very proud to have worked on. So thank you again to NCSEA for the award. We appreciate it.
In the new buildings $30 million to $80 million category, the winners are the Apple Park Visitor Center. The Apple Park Visitor Center is dominated by a large column-free space with a significantly cantilevered and tapered roof system. To achieve such a large column-free space with dramatic cantilevers, while minimizing deflections in the glazing and carbon fiber roof systems, the building utilizes a novel post-tension steel roof structure that cantilevers nearly 50 feet from the core of the building. California State Polytechnic University, Pomona Student Services Building. Cal Poly's 138,400 square foot Student Services Building serves as the primary campus entry and is comprised of two structures separated by a spacious breezeway. Structural ingenuity is highlighted through a streamlined undulating roof that serves an essential role in passive solar design. From design creativity through construction planning, the roofscape was the result of creativity and know-how to heighten beauty and efficiency. Casa Adelante. Casa Adelante is a seismically resilient 9-story affordable housing project for low-income seniors. The specially tuned reinforced concrete building uses self-centering walls on a rocking mat foundation. Lead extrusion dampers within the foundation control the seismic response. The building has been evaluated to have 0 days of downtime for repair after a major earthquake and received a gold rating from the U.S. Resilience Council. The high-performance cost premium was near zero, with only 0.24% extra cost. The North Surrey Sport and Ice Complex, hybrid timber roof. The North Surrey Sport and Ice Complex features 3 ice arenas with curved, long-span hybrid timber roofs and venues for lacrosse, basketball, and trade shows, as well as a cafe. Lark Group, as design builder, gathered a team including Structure Craft as engineer builder for the roof structure to deliver this project. And the 2020 Outstanding Project in the new building's $30 million to $80 million category goes to Casa Adelante.
In the creation of Casa Adelante, engineers developed an innovative foundation damper system that will reduce the seismic load on this building. This development helps to create a 0-day downtime for the residents of this housing project after a major earthquake. Why is this important, you ask? Because this is not a traditional housing complex. Casa Adelante was built to meet the needs of the city of San Francisco. This complex houses residents who are considered to be low income with limited resources and also houses previously homeless senior citizens. This ensures that some of the most vulnerable populations of the city will have homes following a major earthquake. Beyond this impressiveness, the building was designed as a high-performance seismic building with no additional construction costs to the overall project.
As mentioned, Casa Adelante is 100% affordable senior housing, and 25% of the units are for formerly homeless seniors. These are folks that don't have a lot of resources, and our goal is to keep them in their homes after an earthquake by providing resilience to this building. The biggest challenge was to deliver resilience without additional cost. And this means making a building that can survive a maximum considered earthquake, deform and recenter, realign without structural damage. We're extremely proud of our accomplishment. Casa Adelante is the first multi-unit housing built structure to receive a gold rating from the U.S. Resilience Council. I want to thank a couple individuals especially. The first is Professor Jeff Rogers at the University of Canterbury. Jeff developed, tested, and even subsidized the lead extrusion foundation dampers that were key to the resilience strategy. All of Jeff's efforts were pro bono. I'd also want to thank Professor Greg Dearline at Stanford. Greg was our peer reviewer, and his efforts were also pro bono. The third is Evan Reese at the U.S. Resilience Council. The USRC waived all their fees for the cause of low-cost resilience. And finally, the entire community of folks that are in the design and development business trying to alleviate the housing crisis in California. Thank you.
In the new building's $80 million to $200 million category, the winners are the Charles Library at Temple University. The Charles Library at Temple University, at 4 stories and 220,000 square feet, employs a combination of large cantilevers and long-span arches. It features a 47,300 square foot building-wide green roof, a 3D printing workshop, and virtual reality space, as well as a 3-story tall automated book storage and retrieval system that condenses the library's collection into high-density storage units. The International Spy Museum. The International Spy Museum in Washington, D.C. is a 130,000 square foot distinctively designed steel building that incorporates exposed sloping columns along the south and west faces that are part of the building's gravity load carrying system and support an intricate series of exposed steel monumental stairs and platforms, as well as a 60-foot tall glass veil. The museum is tailored to present state-of-the-art exhibits and installations to promote public understanding of intelligence and espionage. University of Michigan Biological Sciences Building. The Biological Sciences Building at the University of Michigan is a first-of-its-kind facility integrating science education with innovative research space and an interactive museum to engage the public and revolutionize research, discovery, and communication. The coupling of a major academic sciences program with a museum of natural history opens the life sciences to the public via the intertwining of the museum and research space. And the 2020 Outstanding Project in the new building's $80 million to $200 million category goes to the International Spy Museum.
The International Spy Museum stood out to the judging committee due to the following conditions. The geometry of the building posed a challenge that required several structural solutions. The design team had to address the lateral drift due to the gravity loads of the building. The Spy Museum also boasts unique exposed structures such as L-shaped sloped columns constructed of steel plates. Lastly, below this building lied an existing building that required significant reinforcement for the construction of the Spy Museum. The reinforcing was designed to allow the existing building to stay open and active during construction.
The Spy Museum project was a renovation project, a major structural strengthening project, had a challenging and innovative architectural design, and was a vertical expansion. All this on an occupied facility. One of these prior characteristics would usually make a project more challenging. Having them all on one site made it that much more structurally unique. We would like to thank the NCSCA and the local chapter, the SCAMW, for their contributions to the profession. We'd like to thank the project team outside the firm, all the architects, contractors, and other design professionals working on the project. The It takes a lot of talent and collaboration to put together a project like the Spy Museum. We had a great team of professionals. We'd definitely be remiss to not single out RSHMP and Hickok Cole Architects for the outstanding architecture and personnel they had on the project. We'd like to thank the ownership, the Mallwright Companies, and Milton and Tamar Maltz for their vision, dedication, and opportunity they gave the team. We'd like to thank their CFO, James Gomez, and the developers, the JBG companies, for the leadership and day-to-day direction they provided. Lastly, and most importantly, I'm thankful to the project team we had at SK&A, project manager Daniel Cacciardi and project engineers Jonathan Gallus and Catherine Pasteur for their hard work through nights and weekends on this project. Without your dedication, it would not have happened. Thank you.
In the new buildings over $200 million category, the winners are the Academy Museum of Motion Pictures. The Academy Museum of Motion Pictures, designed by Renzo Piano, consists of a major renovation to the 1930s streamlined modern May Company building, later renamed the Saban Building, plus a soaring spherical addition housing a 1,000-seat theater. The Saban Building's original steel and concrete structure required strengthening to resist an earthquake's force. For the 150-foot diameter orb-shaped theater addition, an unusual base isolation system allows the theater to move 30 inches in any direction during an earthquake. New Stanford Hospital. The new Stanford Hospital represents the latest in seismic resiliency technology. A base-isolated steel moment frame structure was designed for functional recovery performance following a major seismic event. Additionally, NYA's resilience-based design provided enhanced protection for critical non-structural elements, with the goal of providing a functional hospital following a major seismic event. W Hotel Tower. The dramatic 41-story W Hotel Tower incorporates North America's largest use of a seismic design innovation recently pioneered by the engineer of record. It was constructed of cast-in-place concrete with two-way flat plates in the hotel residential tower and a combination of one-way and two-way post-tension slabs in the podium and parking. Concrete shear walls resist seismic loads for both the tower and podium. And the 2020 Outstanding Project in the New Buildings Over $200 Million category goes to the Academy Museum of Motion Pictures.
The museum incorporates a remodel of an existing 1930s building and a spherical addition that houses a 1,000-seat theater. This stood out to the judges because the theater has an unusual and creative base isolation system that allows it to move up to 30 inches during an earthquake. The design by Burrow Happold required a creative solution for the connections between the two buildings that are both flexible and allowed to both pivot and rotate.
Thank you very much. It's a great honor to receive this award on behalf of Burrow Happold and all of the people who are involved. I would especially like to thank a few individuals, Andy Rastetter, Jamie Chung, David Z, and Chase Kosak played exceptionally large roles in the project. I could not have done this without them. The project had some great structural engineering challenges, including the use of base isolation itself. Figuring out how to design and build a spherical concrete structure that's only supported on 4 plinths was a challenge. But really, the connecting the structure to the adjacent museum and with architecturally exposed glass and steel bridges and allowing them to move 30 inches was probably the biggest challenge, and a lot of fun. But beyond that and the pure engineering bits, it was really the collaboration with the architects that was the most, really the most wonderful part of the project. Seeing how engineering can inform and change the architectural form of the building. And then as we moved into construction, seeing how the way it needed to be constructed further changed, even the form and the structure itself. So it was a collaboration among a huge number of people. Again, I'm very happy and excited to accept the award. Thank you.
On behalf of the Board of Directors, congratulations to all of our award winners for their amazing accomplishments and dedication to the profession. We look forward to October 2021, when we all hope to be together again to celebrate structural engineering at the NCSEA Summit in New York.